Anytime you come across a system with multiple Nexias, multiple Audias, or audio with expanders, the audio will be bussed between devices with Nexlink for Nexia and via CobraNet protocol for audio. What exactly is CobraNet giving us? It allows uncompressed audio over Ethernet networks with a very low latency. To be clear, CobraNet is a third-party technology. Biamp licenses a 32 by 32 channel implementation of it. We use it to send audio between AudioFlex chassis whenever there is more than one in a system, connect peripheral Biamp devices like the I/O expanders to Audia, connect to other devices that utilize the CobraNet protocol. To evaluate problems in a multi-device system that uses CobraNet, there's some vocabulary we'll have to define and understand. Within a CobraNet network, we'll have transmitters and receivers. They are, quite simply, devices that encode a signal and devices that decode a signal, respectively. One device in the system will become what's called a conductor. One of the most important roles the conductor plays is to set the master clock in the system so that all devices are synced up, which is imperative for hearing the right thing at the right time. It does this by sending out a timing packet called a beat packet at the rate of 750 per second. All the devices on the network take this signal and match their clock to it. The conductor also negotiates the flow of CobraNet audio traffic by giving permission to each device on the network that wants to transmit a signal and keeping tabs on them so that devices don't step on each other. It does this via bundles. Think of a bundle simply as a container of up to 8 channels of audio and represented by a number. These bundle numbers are defined in ranges for different applications. It breaks down like this. Bundles number 1 through 255 are for multicast traffic transmission. Multicast lets a single signal go to multiple receivers on the network. This may be necessary in a scenario where you have a paging feed, for example. This is very convenient, but the downside is that you use a lot of bandwidth as the transmission is sent to every receiver on the network, whether they need to hear it or not. The official best practice recommendation for CobraNet and multicast is that you limit a single network to no more than 4 multicast bundles. Numbers 256 through 61,439 are for unicast traffic, or one source to one destination routing on the network. The bundles above 61,439 are private bundles, reserved for manufacturers and their software use, and so you won't have to deal with those. Speaking practically, the way we work with these bundles in the audio software falls into 2 categories: explicit and implicit. Explicit bundles are those in which a person specifies the number between 1 and 61,439 and applies it in their design. We use them for any peripheral CobraNet-enabled device like the Biamp expanders or third-party interfaces. In this case, you'll see CobraNet input and/or output blocks in the audio file, which represent CobraNet audio connections to or from those types of devices. Here are a number of CobraNet blocks side by side in the file with other DSP blocks. A look at their control dialogs shows that we have gone in and set bundle numbers for each. The other category of bundle is what we call implicit CobraNet. These are unicast bundles that the software compiler automatically defines for CobraNet between AudioFlex units. those are the bundles above 61,439. They are represented by dotted blue lines in the software. So when you see those blue lines in the design, you know they represent audio traveling between audias over the implicit CobraNet network. Here's a look at the same file we just saw, but now there are two audio devices in this system as evidenced by the device IDs. The blue lines show implicit CobraNet jumps between units 1 and 2. Aside from those ranges, an important thing to remember about bundles is that only one device can transmit on a bundle at a time. That is, you cannot have some sources from device A and some sources from device B simultaneously transmitting on the same bundle number. As far as the bundle capacity and restrictions go, CobraNet is going to give you the ability to do up to 32 by 32 channels of audio within a maximum of 16 transmit and 16 receive bundles. In this case, you would be using 2-channel bundles. The last CobraNet parameter we will define here for the purposes of working on an existing system is the latency setting, which defines the rate of packet transmission. There are 3 setting options here, and the most commonly used one is 5 1/3 milliseconds, which is the inherent latency of the interface. In other words, the time that it takes to input a signal, have it go through sampling and digital conversion, and eventually make its way back out into analog audio again. The latency can be lowered, but at the price of decreased switch hops and/or channel count. The lower settings available are 2 2/3 milliseconds and 1 1/3 milliseconds. Some items you have to make sure of regarding latency are that latency must match system-wide. Systems with mismatched latency settings will not be able to transmit audio between each other. And the forwarding delay of your Ethernet network must be less than the CobraNet latency setting. So, if it takes a packet 2 milliseconds to get across your network, a CobraNet latency of 1 1/3 milliseconds is not going to work. Finally, your CobraNet latency latency will affect the maximum number of switch hops that can be used in the network. Here are the switch hop numbers that CobraNet recommends. These guidelines are for 100 megabit switches, and so you can get away with more these days with a faster switch. At 5 1/3 milliseconds, you can have a total of 7 switches with a full 32 by 32 channel count. At 2 2/3 milliseconds, you can have 3 total switches and the same full channel count. At 1 1/3, you can have 1 total switch, but the channel count halves for a total of 32 channels, essentially creating a digital snake cable. Setting the CobraNet latency is done in the equipment table. Remember, this needs to be a global value per system. If you're replacing a device in a multi-unit system, you'll have to be sure this setting is right in order for it to communicate with everything else. The best practice for preserving the fragile integrity of the timing requirements is to isolate the CobraNet traffic either physically or on a VLAN. If you're running into trouble with a CobraNet network that's on a corporate LAN, make sure it's on an isolated VLAN and that audio is prioritized in any QoS scheme that may be set up. You'll notice there are 2 CobraNet ports on the back of an AudioFlex, one labeled primary and one labeled secondary. You will want to be sure that the primary port is the one being used unless a redundant network is also present. A redundant network would take over in the case of a failure in the primary. Let's take a look at what this means. First, it's worth pointing out here that in a multiple device system, All that's needed is to connect the primary CobraNet ports of each audio to the same switch, and your CobraNet network is basically all set up. To start adding redundancy, add an additional switch and connect the secondary CobraNet ports of each audio to it. To further redundancy, link the two switches together. For full redundancy, add a second link between switches in the case of the failure of the first link. Be sure to enable spanning tree protocol on your switches in this final scenario. If you're tasked with setting up a redundant network, make sure it looks something like this. More details about CobraNet setups as they relate to our products can be found on support.biamp.com.